that I posted. In fact, just to make things perfectly clear, and I know most of you do this, if you're absent, I mean, it's good that you email me to let me know that you're absent. You don't have to, though, but I appreciate it when you do. If you're absent, you should be going into Google Classroom and seeing what's happening there. And, if you're absent, you need to know that when I have many absences, I record the lesson and I post it. But the lesson wouldn't be posted on YouTube until, maybe 5 o'clock. It depends what's going on, because it takes a while for me to, sometimes I have to edit the video a bit, and then it takes about half an hour to upload it. But sometimes I have a meeting after school. So, if you check into Google Classroom and you don't see anything there when you're absent, that doesn't mean we didn't do anything. It just means you got to wait a little bit longer to find out what we did. And the expectation, I think you know this, is we move on to the next lesson every day. Right? We don't. Have we had a day where we just did nothing? I don't think so. Unfortunately, that's just the nature of this course. We always have to move on. So yesterday we looked at multiplying rational expressions. And basically the bottom line is when you multiply fractions together, you end up with one gigantic fraction, because you end up multiplying across the top and you end up multiplying across the bottom. So, for example, if you take a look at 1b, for all intents and purposes, this is what 1b says. I know it says that. We're multiplying two rational expressions, but when you put them together, you have to multiply across the top, multiply across the bottom. So you're dealing with a single rational expression, which means, this is interesting, you've turned it into a question that we learned on the very first day of this unit. How do you simplify a rational expression? You cancel factors that appear in the numerator and in the denominator. How you handle that 3 on the top and the 15 on the bottom is up to you. But just to make sure that you understand we're keeping with the rules that I've given you, there's a 3 on the top, there's a 15 on the bottom, which is a 3 times 5. So you are canceling a factor of 3. I know you're probably not going to write 3 times 5 and do it that way. You're probably just going to change it to 1 over 5. Anyway, that's the bottom line. Remember, again, that you continue to compile or list your non-permissible values before any canceling has occurred. Take a look over your work. Does anybody have any questions you would like me to go over? Essentially, so far in this unit, what this unit is a test of is your ability to factor, isn't it? I mean, the canceling stuff is pretty easy. Getting to the point where you're going to cancel means you have to factor first. So no questions. Okay, so we're going to go through another lesson today. I think because there were no questions, we're going to have some time at the end of the class where I can hand back your exams. But primarily, I'm thinking tomorrow during seminar is the time for you to look at your exams and for me to help you with them. A couple of you have asked me about rewrites for this last unit. When you take a look at this last unit, nothing really specifically in it is all that challenging. There's just so much of everything. It's why typically students kind of stumble in this unit. Rewrites will be Tuesday after school of next week and Thursday after school of next week. Okay, so once you get a chance to take a look at your exam, you can make that decision if you want to rewrite or not. Today we're going to be looking at the second part of textbook section 6.2, which is how to divide rational expressions. And, I find this interesting. I love this philosophy in teaching math. You take stuff that's new and you turn it into something that you already knew how to do. So, for example, and I just mentioned this a minute ago, when I ask you to multiply rational expressions, you end up turning it into a single rational expression, and we learned how to simplify a single rational expression before we learned how to multiply them. Well, we're going to do the same thing just one step further here. When you divide rational expressions, we're going to turn it into a multiplication instead. That's what we're going to end up doing. So every problem that we look at today is going to be turned into a problem that we knew how to do yesterday, which could be turned into a problem that we knew how to do the day before. There's one little twist here, and it has to do with non-permissible values. So we're dividing rational expressions and stating non-permissible values. And I take you back to junior high, probably junior high, which is where you learned this rule. Quite often in math, a formal rule is the way to go. How many of you remember in junior high trying to be taught how to divide fractions with algebra tiles and stuff like that? I don't want you to agree just because I want you to agree. I'm asking you, did you find that easy to understand? No, you did not. And I've always had an issue with that. When somebody came up with this idea about 30 years ago and they showed all us teachers, I went, well, that's really interesting, but I don't think anybody's going to understand it. And students don't. So we come up with a formal rule, and we have to accept that the rule is going to work. When you divide one fraction by another, it's equivalent to multiplying the first fraction by the reciprocal of the other. It's like, instead of adding 5, you could take away -5. You can do the opposite in mathematics. So you can convince yourself that this is the case. I do want you to notice here what's happened. This fraction that we're dividing by, which is c over d, has changed to d over c, and it's gone from dividing to multiplying. This is the rule that we can use for dividing fractions. So for example, just an illustration here. Let's try this with some numbers. Do I have some here? No. Let's make up two fractions. Let's make up 2/7, and we're going to divide that by 3/5. This is, honestly, dividing fractions is one area in math where I do not even attempt to explain the meaning of it. You know, this is saying how many 3/5 fits into 2/7. What does it even mean? And I have a hard time wrapping my head around it. They're just numbers though, so ultimately if I take 2 divided by 7 in brackets, divided by in brackets 3 divided by 5, I get this number. If you're interested, we could convert it to a fraction, but that's not going to be very helpful with rational expressions. Anyway, it's 0.476. I'm telling you apparently that this is the same as 2/7 multiplied by 5/3. Well, let's try that. Let's take in brackets 2 divided by 7. And we're going to multiply, instead of dividing by 3/5, we're multiplying by 5 over 3. Holy smokes, look at that. We get the same number. So, I mean, this is something that you should be very familiar with. Instead of dividing by a fraction, you multiply by the reciprocal. That's the rule. So now I have a question. In this expression where I have, and they're actually rational expressions. The first rational expression is a over b, and I'm going to divide by c over d. What are the non-permissible values? So I want everybody to take a minute and write down under this question the non-permissible values, which should be statements that say what variables are allowed, or better yet, not allowed to be equal to. And I think it's pretty obvious that b is not allowed to be 0. Because if b is 0, then that first fraction is undefined. It doesn't even exist. And I think it's also clear that d is not allowed to be 0, because if d is equal to 0, then the second fraction does not exist. Right? This, and there's no need to write this down, just doesn't exist. It has no meaning. This, same kind of thing. That's just my kind of puzzled face. I'm confused by it. It doesn't exist. It doesn't make sense. Are there any other variables that are not allowed to be 0 in this expression? The answer is yes. There's one other one, and it's c. c is not allowed to be 0. And I know that when I ask everybody to try to come up with a reason why C cannot be 0, most people say, well, I'll ask you. Can somebody volunteer an answer as to why you think C is not allowed to be 0? Isaac? Right. So this is what most people will say, and there's nothing wrong with it. There's a slightly better way to explain it, though, or a slightly different way. What Isaac said is, if you've already been told that A over B divided by C over D is going to morph into A over B multiplied by D over C, all of a sudden C becomes a denominator, and there's nothing wrong with that logic. Okay? Is there another reason, though, why we would say that C is not allowed to be 0? Oh, Isaac again. I'm going to just tweak that a little bit. Yes, you're right. But I'm going to say if C is 0, then C over D is 0 over D, which is 0. If C is 0, that whole second fraction is 0, right? And you're dividing by it. It says A over B divided by C over D. And if this becomes 0, then you've got A over B, whatever that is, you're going to try to divide that by 0, and that can't be possible. So what I'm telling you, and this is the general rule that you want to take away from this, I'm going to erase all of this. This was just my explanation and ramblings on paper, is that when you were dividing two rational expressions, remember how I told you you always eyeball the denominator to determine non-permissible values? I hope so. Well, what you have to eyeball here is every denominator and every numerator of a fraction that you're dividing by. Because if the numerator of that fraction you're dividing by is 0, then that fraction becomes 0 and you can't divide by 0. Or if you like, those fractions are going to be flipped over, so the numerator ends up becoming a denominator anyway. Other than that, you should be able to do every single question here. We're going to continue to practice because we need practice with factoring and canceling. There's an issue here, though. We can do the non-permissible values first. A, B, and C are all not allowed to be 0. Are A and B not allowed to be 0 because there's A's and B's up here? No. It's because there's A's and B's on the top of the fraction that you're dividing by, or, as I just saw somebody do in the air, they took their two fingers and they did this, they flipped something over. They're saying the fraction you're dividing by, you're going to flip over, and those A's and B's in that fraction become a denominator. Now, I would always rewrite the question with a multiplication sign first. I know there's going to be a temptation for you to do a lot at once here. You're going to want to factor and flip at the same time sometimes, and I don't think that's a good idea. I don't. It's going to be confusing. You'll make a mistake. So the first thing you're going to want to do is just take 35a squared b squared over 5c and multiply by 10c over 21a to the 4b and double check everything very carefully. We've turned it into a Wednesday problem, a problem that we knew how to do yesterday. You remember doing a problem like this yesterday where I wrote, well, I'm going to write it out. You don't have to. You don't have to write out what I'm about to write. You know what I'm talking about here? So I want you to understand that because all of these things are monomials, you don't have to write things in factored form. You have to be able to get the right answer. Okay? But there might be the odd person or two or three out there that need to see this in order to know what they're canceling and know what they have left. On the bottom, I have a 5 and a C as factors. I have 21, which is 3 times 7. And then I have A times A times A times A times B. And I think, well, I don't know. I think many of you would agree that this is actually more confusing. For me, anyway, I could see myself making a mistake here by doing all of this. So I'm going to double check everything. You help me out here. Just check to see if the top is all factored correctly, and it is, I believe. So is the bottom. Are we in agreement there? Starting to see some nods. So 5 and 5. I thought I saw a 7 and a 7. There's definitely an A and an A and another A and another A. What else do we have? We have a B on the top, a B on the bottom. We have a C on the top, a C on the bottom. The only thing I have left on the bottom is a 3 and an A squared, and I don't see a 3 or an A on the top. So all I have on the top is 10B over 3A squared. Are we in agreement there? What's very interesting is A, B, and C are not allowed to be equal to 0. There isn't even a C in the expression, but it doesn't matter. You need to say that. I believe it's simpler, forgetting about the numbers, it's simpler to simply say I have A squared on the top and A to the 4 on the bottom. So that leaves me, after I cancel the A squared on the bottom. I have a C on the top and the bottom, which are gone. I have a B squared on the top and a B on the bottom, which gives me a B. And then you can crunch the numbers. So when they're monomials, man, this writing out all of these A's and B's and 2's and 3's and 5's and 7's, that's a real drag. And it can actually get in the way of you getting the right answer. So what do I care about? That you end up with 10 over 3 here. I would still avoid doing this on paper. I think that gets messy. If you have to figure out what that number is, just do it off on the side someplace, or heck, throw it in your calculator if you have to. That's not a big deal. All right, you cannot take any shortcuts here though. So the first thing we're going to do is, well, this is tricky. You have to do the non-permissible values before you cancel, right? And you have to flip this before you cancel. So again, I'm thinking flip it first, then factor it. Really, a part of me, everybody, a part of me wants to factor everything and flip at the same time, and I make mistakes. You will as well, guaranteed. So I would just flip it. It only takes a second. If you're feeling daring, then you can flip and factor. But I'm going to have x squared minus 9 on the bottom and x squared plus 6x plus 8. How many of you look at this though and go, oh, that shouldn't be that hard to flip and factor it simultaneously? That's the immediate impression most students have, but it's very easy to make a mistake. So double check to make sure you flipped correctly. There's a technical math term, flip. We've taken the reciprocal of the second fraction. Now what we're going to do is we're going to factor. Now we're going to factor. I don't think we want, again, to flip and factor. You flipped, now you're going to factor. So we have x minus 3 over x plus 4, and then it's multiplied by, this is, I hope even as we work through much of this material, your factoring skills continue to improve. They're probably getting better. The bottom is a difference of squares, so we have x plus 3, x minus 3. The top is a basic trinomial. We can factor it into x plus 2, x plus 4. And I'm going to do the same thing that I was talking about doing yesterday, which is that I don't think it's necessary for me to draw a line between both fractions. I can. So sometimes I will do that and sometimes I won't. I am allowed to, at this point in time, cancel the x minus 3's. I am allowed to cancel the x plus 4's. And I'm left with, well, what am I left with? X plus 2 over x plus 3. And I have to state my non-permissible values. X is not allowed to be equal to, but you know, I have canceled some stuff off, but I still want to look for my non-permissible values. I still want to look here, here, which was the original denominator of the second expression, and here, which was the original numerator of the second expression. I got to list all non-permissible values related to those factors. So I have -4, I have -2, I have plus or minus 3. And that's it. Any questions with that one? All right. Well, let's do the same thing again. By the way, some of you might decide to factor everything first, then flip it. That's okay. There's nothing wrong with doing that. Just don't do them both at the same time. I don't do that, by the way. I like to flip it. Now let's factor and cancel. It gets kind of boring after a while. There's no real challenge other than the grunt work of factoring everything. 9x squared minus 4 is a difference of squares. It factors into 3x plus 2, 3x minus 2, and then we have an x plus 3 on the bottom. 3x plus 9 has a common factor of 3, and if we factor that 3 out, we have x plus 3 remaining, and I can factor a 2 out of the denominator here and be left with 3x minus 2. Let's do our non-permissible values first before we cover them up maybe with canceling. I look at the bottom of the first fraction and I say x cannot equal to -3. I look at the top and the bottom of the second fraction because the top was originally a denominator. Well, that's -3 as well. And then also we have 2/3. I just want to make sure you understand where I'm getting 2/3 from. I'm looking at this denominator here and saying that 3x minus 2 is not allowed to be 0 because then you would be dividing by 0, and I'm solving that for x. What can we cancel? Well, I've got an x plus 3 and an x plus 3. I've got a 3x minus 2 and a 3x minus 2. And that's it. Whatever I have left is the answer as long as I state those non-permissible values. So I have 3 times 3x plus 2 over 2. This is my answer. Capiche? Ariana.
For the 3x plus 9, would there be like a -1 that x not equal to? Like, doesn't that one also have to have a non-permissible?
Yes. But if you take 3x plus 9 and set it not equal to 0 and solve it, what will you get for what x is not allowed to be? Well, we subtract 9 from both sides and get -9, and then we have to divide by 3, so we get -9 over 3, which is -3. We get x is not equal to -3. And we already had that one, but the other point I want to make is since this is the 3x minus, or the 3x plus 9, we don't have to worry about solving this. We just eyeball the x plus 3 and go, oh, there's a -3. Are you sure? Okay. Any other questions with that one? Phew. Well, it's time to get to work, I guess, eh? So, first thing to note is you're dividing by a fraction and then you're continuing to divide by another fraction. So your non-permissible values are going to be found by exploring every denominator in the original problem plus any numerator of a fraction you're dividing by, because when you divide by a fraction, you have to flip that fraction over. So keep in mind that the only thing we're not going to look at for non-permissible values is the numerator of the very first fraction. That's it. Boy, there's a lot to write down here, and there's a lot of room for error, which I hope you can see that if you tried to factor and do all of this at the same time, you'd probably make a mistake. So all I'm doing is rewriting it, and every fraction that I was dividing by, I am flipping over. And then I'm going to go back and double check, which is what you should be doing as well. I really think double checking this first step is important, because this is what sets the stage for everything that you do. If you write down a number wrong, well, everything's wrong after that. But I think it looks okay. Would you be in agreement? Okay, so now we're off in factoring mode. Luckily, these are all easy to factor, I think, because it's 1m squared in all of these. The numerator of the first fraction would factor into m and m, two numbers that multiply to give -4 and add to give -3 would be -4 and 1. The denominator I can factor an m out of. Over here, two basic binomial products for each of those. Two numbers that multiply to give -15 and add to give 2. Why am I having a hard time with that? Oh, 5 and -3. M plus 5, m minus 3. Bottom, two numbers that multiply to give 12 and add to give -7. That would be, boy, I'm really struggling today, -3 and -4. So m minus 3, m minus 4. And then we also have a common factor of m in the numerator here. We can factor an m out and be left with m plus 3. And the denominator is a difference of squares, m plus 3, m minus 3. So again, I'm just highlighting this for maybe people on the video, people watching the video so that they know what it is I'm pointing at. All of these factors, all of these factors, these factors, these ones, and these ones are all factors whose zeros will be non-permissible. What I mean is the number for the variable that makes each of them 0 is not allowed. So it's a slow, methodical process. You don't want to miss anything. M is not equal to 0 because there is a factor of m. M is not equal to -5. Wouldn't worry about putting these in order right away. They don't have to be. Just make sure you get them all. -5, so I've taken care of this one, I've taken care of this one, taken care of this one. I haven't got this one, but I'm going to check it off now and put 3. I have taken care of this because it's the same as what I just did. M minus 4 gives me a non-permissible value of 4. And then I have this one, which I've taken care of. I have the m minus 3, which I've taken care of. I'm going to do the m plus 3 right now, which gives me a non-permissible value of -3. I'm just going to put plus or minus in front of that 3. You can write -3 if you like. And then it's slash and burn time. And by the way, even though I've highlighted all those things, you can cancel anything now. Anywhere, as long as it's on the top somewhere and on the bottom somewhere. So do I have an m minus 4? I do, m minus 4, m minus 4. I have an m, I saw one over here. I have an m plus 3 while I'm over here. I have an m minus 3. Oh my goodness, I have an m plus 5 Everything's gone except for the m plus 1, it looks like. Am I missing something? And the m minus 3, thank you. I have these two left. And, you know, probably, I'm not making excuses, but probably since you're not cluttering things up with color, you can see what's left over a lot easier. So you're left with m plus 1 over m minus 3. This is our answer, m plus 1 over m minus 3, as long as m is not equal to 0, -5, plus or minus 3, or 4. It's not difficult. If you can factor, this is an easy unit so far. It'll get a little more difficult in the coming days. So this one's going to be more challenging because you have 4 quadratic trinomials that you're going to factor that all require trial and error because they're not 1 x squared. So let's rewrite it as the product of the reciprocal of the second one. And again, you want to just maybe double check that you've flipped things over properly. This will be 4x squared plus 4x plus 1 on the bottom. It looks like I've transcribed everything correctly. In other words, I haven't copied it incorrectly. And I've flipped over the second fraction. So I'll tell you what I'm going to do. Are we in agreement it's written down okay? Okay, so I'm going to give you a few minutes, everyone, to factor all of these. Then we will finish off this lesson. It's a relatively short lesson. Then probably what's going to happen is for at least the next half hour or so, you're going to be working on this, and then I will hand back your exams for the last 15 minutes or so you can look at them.